So hi guys, so today I will be doing the magnetism, not magnetism, moving charges and numericals basically, moving charges and magnetism, chapter number 4 in physics. Because I always get confused with chapter number 4 and chapter number 5. So chapter number 5 is magnetism matter, and this is some moving charges and magnetism, I think so. Yeah. So first thing, we'll do the easiest questions first. Question number 6. Is everyone able to see the screen? I'll ask Misbah. Then, Nagesh, Kushi, Yutika. Yeah, I think fine. I hope my voice is also audible. So again, coming to this, a galvanometer of resistance 50 ohm. How do you convert a galvanometer into ammeter? So to convert galvanometer to ammeter, it has to be connected in parallel. That is, shunt resistance will come. Correct? So S is equal to what? Ig into G by I minus Ig. The formula we have to know. Direct substitution. Galvanometer current. What is written here? 2 milliampere. It will be very, very small. Compared to the actual current, total current, the galvanometer current will be very, very small. It will be like milli or something. The moment you see milli or something, it is galvanometer current. So substitute that. And what is this? G, capital G is the resistance, 50 ohms. Correct? Yeah. And what is total current? 3 amps. Maximum is 0 to 3. So 3 minus 0, it is 3 only. And again, putting 2 in 10 power minus 3. Then once you do the calculation, you'll get this thing. Then to convert galvanometer to voltmeter, R is equal to V by Ig minus G. Simple calculation again. Then we have to calculate what the voltage. Voltage, change in voltage about 6 volts. So 6 by galvanometer current. That is 2 in 10 power minus 3 minus 50. That's it. So then I'll be getting a resistance also to galvanometer to convert galvanometer to voltmeter. Next thing. Again, I can see a deflection. So obviously this will also be what? How to convert the galvanometer into ammeter. Same formula. S is equal to what? Ig minus I minus Ig. So see the bigger current. Correct? Which is the bigger current? 0.5 ampere. What is this? 5 milliampere. Not 5. That is 5 in 10 power minus 3. Smaller current. Substitute everything, you'll get the answer. And voltmeter, and again to convert it into voltmeter, I'd use what? R is equal to V by Ig minus G. That formula. Simple as that. And always make sure that for the voltmeter, the resistance value will be mostly greater than 1000. Okay, so that is a tip which I'm going to tell you. Mostly the resistance value will be more than 1000. So if you're getting very less than 1000, kindly recheck the calculation. Okay, then let me take this question now. So the prerequisite of this is you have to know the galvanometer derivation, that is how to convert to ammeter and voltmeter. Then only you'll be able to understand. Next one, an electron of, this is the question which I'm going to do. An electron of energy 1000 eV describes a circle in a magnetic field of strength. It's given something. Calculate the radius of the circle. This is 0.02 Tesla. This one I'm talking about. Okay, Then they given charge of an electron 1.6 10 power minus 90, mass 9.1 10 power minus 8. This and all we have done in a lot of problems, so we should be thorough with this. Kinetic energy, there is even moving energy. Kinetic energy is what given? Electron of energy describes a circle, so it's moving. So moving energy is called what? Kinetic. Okay, that they are given. Electron volt. How do we convert electron volt to joules? Multiply by what? Charge of an electron? 1.6 in 10 power minus 9. How to convert electron volt to joules? This is electron volt, this is to joules. Multiply by 1.6 in 10 power minus 90. Okay, and kinetic energy, we know the formula, half mv square. Correct? So 2 k is equal to what? Mv square. So you define what? The v from it, the velocity. Substitute everything and we'll get it. That's all. Simple as that. Okay. And also we know what momentum P is equal to what BQV, mass into velocity is equal to what? This is my BQ. MVR is what is the formula? MV by BQ or QB. Substitute everything and you'll be getting the answer for R. Then F is equal to BQV if you do it. F is equal to QVB or BQV or whatever it is. Q, charge of an electron, 1.6 into 10 power minus 90. B is already given in the question, that is Tesla. B is magnetic field, the unit is Tesla. T it will be given. So once you see the question, you'll be able to get it down. So to go back to the question, you'll be able to get it. Now let me come back to the first question. A straight wire of length pi by 2 is bent in a circular shape. Okay. Yeah, then they ask us what called the magnitude. Whenever we are having magnitude, it is root of square of something. Okay. And we all know the formula. What is it? B is equal to mu naught by 4 pi. What is mu naught value? 4 pi into 10 power minus 7. Mu naught value is 4 pi into 10 power minus 7. This one, write it here. 4 pi into 10 power minus 7. Okay, 10 power minus 7. I'm just writing like this. That is nothing but mu naught value. Mu naught value. So mu naught by 4 pi, what is the value? 10 power minus 7. Because 4 pi and 4 pi will get cancelled. Clear? Yeah. So with this, I'm just raising this. So we know the formula, magnetic field at a point P on the axis of a current loop is what? This already we had done a derivation. B is equal to mu naught by 4 pi, 2 pi n I r square by r square plus x square the whole power 3 by 2. Correct? Yes. So how to get the magnetic field B in a center of current loop? Mu naught by 4 pi into 2 pi ni by r. That is the formula. So if I substitute everything, I'll be able to get what? What I'll be getting? I'll be able to get the magnetic field value. In the sense here, as you can see, a straight wire of length pi by 2 is bent into a circular shape. O is center of circle formed and P is a point on its axis, which is a distance 3 times the radius from O. A current of 1 ampere is passed through it. Calculate the magnitude of the magnetic field at the points O and P. Magnitude of the magnetic field at the points O and P. P is a point on its axis, which is distance 3 times the center. So x is equal to what? 3r. Correct? And also, what they given? Straight wire of length pi by 2. Length of the wire is pi by 2. Correct? Yeah. So this 2 pi r is equal to what? Circumference is equal to what? Pi by 2. Length of the wire is nothing but it is circumscribed in a circle, right? So the length will be equal to what? It's already given pi by 2. So 2 pi r is equal to pi by 2. Correct? Yeah. B is equal to the formula we'll be using. You'll get the value of B. And then magnetic field at a point. That already the derivation I taught you. The same thing you have to substitute. Then I'll be getting the value of B through that. Direct substitution. Only thing is 4 pi and 4 pi will get cancelled. So mu naught by 4 pi value is 10 power minus 7. The rest of the things, it is simple calculation. R 0.25, X 3 times R, so 0.75. So calculation. Next one. A circular coil of wire consisting of 100 turns. Each of radius 8 cm carries a current of 4. What is magnitude of magnetic field at the center of the coil? See guys, and one more thing I will tell you. Any doubt is there. Suppose in examination, if you are unable to understand the question, whatever magnetic field formulas you know, write it down. And then fill the variables. Okay, if you're not able to understand the question, just don't leave it. Sometimes once you fill the variables, we'll get the correct answer. 100% will be getting it. Okay, there are only few formulas in magnetic field, so don't try to understand the question too much. That time we might fall into trouble. Clear? Yeah. So simple formula. Again, in the formula sheet, you have to add this formula also. N number of turns. 100 turns it's given. I for 0.4. I'm just filling everything. R. What is R? Anything is given here. Radius, centimeter or meter at 8 Newton per minus. Substitute everything, you'll get the answer. Simple. Then they are giving two circular loops. So which means I have to find what B1 and B2. The current and everything will be same. Only the radius will be difference. Okay, current and everything. If you can see here, everything is same except the two things. So so see here, everything is same. Then the resultant is nothing but root of B1 square plus B2 square. That is only my resultant. So once you do it, you will be getting it. Direct question. Yeah. So that's it, guys, then.